So, how do you detect radioactivity? We can't see it, you can't feel it. But we can monitor it based on the interactions between radioactive nuclei and other atoms or molecules. And so we're going to talk just very superficially about some different ways of measuring radiation or radioactivity. This is called a thermoluminescent dosimeter. And this is the sort of thing that if you're, a rad tech or somebody working with radiation in the hospital, you're going to have one of these badges that you wear all the time when you're at work. So the way this one works is it's got crystals of salts, calcium fluoride is one, that become excited by ionizing radiation. And then those excited electrons get trapped by impurities that have been intentionally put in. And so when the crystals are heated, they're going to emit light, luminescence, proportional to the radiation exposure. So the badge itself is not going to glow, but you would wear it for a certain amount of time, maybe weeks or months, depending on your level of exposure, and then you'd trade it in for a new one, and they're going to heat that one up and monitor and see how much radiation you've been exposed to. Any questions? You probably heard of a Geiger counter. Supposed to give Mueller some credit for that too. It's a Geiger-Mueller counter. This measures radioactivity in real time, and this is the kind of thing you see in the movies, right? Where they've got this wand and you're hearing these clicks, right? Click, 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 click. Oh no, it's dangerous, get away, right? Well, how does this work? Well, there's the tube here, which is what this person is holding in their hand. That chamber is filled with argon, and as particles pass through the argon, they create a trail of ionized argon atoms. So this again is based on the ionizing power of whatever radiation. Then we have an applied voltage. If you apply a high voltage between this cathode and the anode on the outside, that will attract those ions. You'll produce an electric signal, and this box has electronics in it that convert that into an audible click or show a meter. This one's an analog. There are also digital ones. Some of them you can turn the sound on or off because you may not want to be clicking all over the place. Right? Any questions? A scintillation counter also measures radioactivity in real time. And so here they're passing the radioactive emissions through something like sodium iodide or cesium iodide that's going to emit either UV or visible light in response to being excited by the energetic particles. It's a little different than the dosimeter, because in the dosimeter, those things get excited as well, but because of the intentional impurities, they get trapped. They're stuck. And so you save them all up and measure them later. This is just happening in real time, and so you can measure the light given off, turn that into an electric signal, and you can read that on a meter. So, any questions?